Hey, welcome back to Weld.com, home of TIG time. Hi, I'm Mr. TIG, and we're continuing our series on the basic setup and fundamentals of TIG welding. And I have a guest with me, Kevin Caron, sculptor artist. Kevin?
Good to be here, sir.
Glad you're here. And this is the second part of the series where we're going to talk about DC welding. And when I talk about DC welding, it's DC negative. So whatever machine that you happen to have, set the machine on DC negative. This particular machine has both AC/DC, so we're going to demonstrate doing some stainless steel, just for fun.
Cool.
And if you've never TIG welded, there's so many little features to it, and it's fun. It has great artistry to it, and I've got the best artist right here.
Oh, so, come on.
So when you got into TIG welding, I mean, exactly how did you get into TIG welding?
I was doing a large stainless sculpture, actually. It was my first stainless piece, and I had started out with my MIG welder with a spool of stainless wire on it, and it was such a mess. It was looking burnt, it was looking ugly. I had to go back and clean everything up. So I decided, let's take the leap, and I went and got a TIG welder and just taught myself how to work from there. One of the very first things I did was I had the ground and the torch backwards.
Okay. So
and that drove me crazy for an hour or so because nothing was working correctly.
So you were on DC positive instead of DC negative.
Right, right.
And those are the mistakes that are made,
right,
and
right.
Everybody makes them.
Right, because it wasn't explained in the book. You know, the manual that I got that came with the machine, that was a whole bunch of, I don't know what language it was, but it wasn't English. You know, it said plug it in, but it never said plug it into the negative side or plug it into the positive side. Because with this machine, with all the inverter TIG machines, you've got both the TIG welder there and you've got a stick welder there. And you want to switch your cables back and forth depending on which function you're using. So that was my first mistake.
Okay,
yeah.
So we're going to recap the TIG torch. The setup that we have today is just my favorite setup. Yours is yours, but I like the gas lens. I like tungsten stick out to be about 1/4 of an inch, primarily so I can see, you know, and that's a big issue. I like the small, short back cap, and I break my tungsten into 3 pieces, and I grind it into a point very much like a pencil. So I'm using 2% thoriated, and you use E3, not a problem, either way. Now, I happen to have 1/16 diameter tungsten. Now, this tungsten will withstand only so many amps before it starts disintegrating.
Right, right.
So you have to determine what that is.
Right. I like the 332nd.
Okay. This tungsten is 1/16 diameter. It'll handle up to about 110 amps before it starts breaking down.
Wow.
Now, the crossover, meaning you can go 1/16 or 332, that becomes a personal preference.
Right.
Now, if I go up to 140 amps, then I absolutely have to change.
Right.
I have to jump up.
Right.
But one of the reasons that I like using the smaller tungsten is the arc cone that comes off there allows you to weld smaller. So if you're trying to get into intricate welding, go smaller. If you have a variety of things, then stick with the 332. So again, I got 1/16. We can change this out, but 332 at any given time.
But now, do you find you can actually adjust the size of the arc cone itself just by how you grind it?
I do. You can grind this thing into a very sharp wedge or a very fine wedge, but the reality behind it is if you want to get a very, very fine arc, it's the distance from your tungsten to your plate or your workpiece. And that's your voltage. So for instance, let's say that I'm almost touching the part when I'm welding.
Which is where you should be to start.
Yeah, I will be welding at probably somewhere between 9 and 12 volts. Now, if I have a distance 1/4 of an inch away, my voltage increases. I mean, I may be up at 20 volts. Now that arc is going to be pretty wide and not very condensed at all. You know, so the whole thing about it is when you first start welding, it's not uncommon to be at quite a distance away. 1/8 of an inch away is common. And as you get better and better and more confident, then you get closer and closer and closer to where you're almost touching the puddle.
Wow.
So that's just part of the coordination. So what we're going to do is we're just going to go through the basics I'd like to always start you out on just bead on plate. Don't worry about getting a fillet weld or a vertical upper. If you don't get this down, you're not going to get better. You know, so start off on a flat plate, and all you're going to do is you're going to start an arc initiation. And I want to talk about that. You get that question of what's high frequency start?
What's high frequency? Why do I need it? You know, can I use the lift start instead, or a scratch start? What's the difference between those? You know, these are all other little questions that I get a lot of times.
Great question. So let's cover those one by one. High frequency is nothing more than when you initiate the arc. Like when I push this pedal, there's a solenoid that kicks on, and it activates the high frequency automatically, and a little arc will jump. It'll jump to the part, and then my arc is stabilized. I can see an arc. Now I don't have to hammer it and get a puddle right away. I can just creep up to it. So that's the nice thing about having a high frequency start. Now that high frequency start, it only stays on just for the time that you initiate the arc, and then it's out of the circuit. Then you do your welding and you start all over again. Now if you don't have high frequency, and you may have a lift start, and if lift start is all you've got, then just know that you literally have to touch the part, then hit your foot control, and then lift. And when you lift, that lift start will initiate.
So you don't tap it?
You don't have to tap it, no. No, when you tap it, that's your scratch start. And if you have a machine that doesn't have any of these features, and you may have to scratch start, you do a kind of a wave by. Very much like stick welding.
Like stick welding,
You know, and you don't try to jam the tungsten in there. In many cases, you just get really close, and the arc it'll initiate.
Cool.
You know, so we'll go ahead and get started. I do want to talk about the foot pedals, because there's all kinds of foot pedals out there.
Can you use this pedal on this machine?
Yes, you can.
Oh, wow.
Yes.
Are they all interchangeable?
They're not all interchangeable, and you have to be very careful, because they're set up on certain ohm resistance. You know, so I mean, if I just automatically hooked that up and ran it, it would probably work, but I may overamp it. You know, and the board would blow, and nobody'd be happy. You know, so you got to be real careful. Make sure you get the right one that matches. And the same thing with the thumb controls. They have a resistor in there. So we're going to set up, we're going to get our gear on, and we're going to do a bead on plate. We're also going to add filler material. When you first start, run a bead without filler material. Get that down to a science. Get very comfortable with the settings of your machine, and then you can start adding fillers. And I want to mention the fillers that we're going to use. So, you know, we have stainless steel here, and we're going to be using a stainless steel filler. This is called 347 stainless. It's used a lot in the racing industry, and it has chromium in it, and it welds up very nicely. It's got a great tensile strength, so you're going to get 80 KSI tensile strength, 80,000 pounds per square inch.
But for guys who are just doing art like I do, is there just like a general purpose? If I went to the welding store and I said, I need a tube of stainless to do some stainless work.
Typically, they'll have what's a 308L. And usually that's on the shelf just about anywhere you go. So 308L, it still has good strength. You'll get 70 KSI out of it. And again, strength isn't the big issue. Well, let's get our gear on, and we'll get started.
So while we're getting set up to do some of the welding, I thought, let's take a quick look at the panel. You got your digital readout, shows your amps or volts depending on which function you're using on the machine. Your starting amps. So when you either push the trigger on the torch, or you step on the pedal and your torch actually starts working, that's the amps it's going to start working at. Whether it'll start, you know, you can set it at 2 amps, you can set it at 50 amps. All depends on what kind of welding you're doing, you know, how you like to do your setups. Your main amps, this is your running amps. This is what you're going to have when you're running at full power, basically. You know, so you can set it up to 200 amps, you know, 50 amps, 100 amps. Your pulse amps, you're going to go from your steady, you know, working amperage, you're going to drop down to whatever your pulse base is, and then it's going to come back up again to wherever your working amperage is, your pulse peak. And that only works if you have your pulse turned on. Otherwise, it's just your main amps, your running amps, what you're welding at. your ending amps as you back off the torch, if you back off the pedal or you push your trigger, this is what it's going to drop down to from, let's say, 100 amps. You push your trigger, it's going to drop down to whatever you have set here. It helps avoid the cratering at the end of the weld. And then it drops off altogether. Your pulse frequency, how often do you get that pulse? Your pulse time, how long is that peak? It goes from your base voltage up to your welding voltage. How long is that peak, and then it drops back down again. Your post flow, when you let your foot off the pedal or you push your trigger, this is how long the gas actually flows to help cool the tungsten and help cool the weld. And then your AC balance, how long, what part of the peak is it? Is it all negative? Is it all positive? Is it all right in neutral? This helps with when you're welding on aluminum. This helps for the cleaning, whether you want more or less. The switches at the bottom, this is your switch for whether you want TIG or you want stick. Your AC or DC switch, the 2T or 4T. 2T, it only runs on the foot pedal. Depending on what you do with the foot pedal, that's what your torch is going to do. If you put it on 4T, then you can run off your trigger on your torch. You just push it, it comes, push it and let go, your arc starts and runs. You don't have to keep your finger on the button. And then you push it again and the arc stops. If you leave it in 2T and work off of your torch button, then it works kind of like your foot pedal. You push it, your arc starts, it stays running as long as you keep your finger on the button. Take your finger off, then it stops. And then this is your pulse switch. You either have a straight line, flat line welding, or you have your pulse, up and down, up and down. And then you have your control for either your foot pedal or for your torch trigger on here. The settings, or the connections on it, your torch hooks up with just a screw on. This also carries the electricity to the torch. This is where the gas comes out of, rather than having one that you push in and twist. This is your connector for your stick welder, for your stinger. You just push it in and twist. The 2T, 4T connection, that goes to the pedal. And then your pedal connector. And then this is just your ground. Pushes in and twists. Very simple setup, very easy to use. And then at the top of it, you've got a power light, show you everything's turned on. And then you have an overheat light if you happen to run into the duty cycle. That'll come on and let you know, hey, it's getting a little hot in here, give me a break. That's it. He's ready, let's go to welding.
Okay, that's a very soft arc initiation. I see you've established a puddle. Looks like you're running about 80, 90, maybe 100 amps. Very smooth. You're running probably around, anywhere from 4 to 6 inches a minute.
So is that good or bad?
That's good. It's very good. The width of your weld is consistent. The height of your arc is consistent. Nice, clear, clean puddle. You can see some material contaminants floating on the top.
Yeah.
That's pretty normal. That's just a little bit of sulfur, a little bit of phosphorus. And for those of you that are just now learning to TIG weld, this is the way to start.
Well, that's pretty sweet. And I can see why you like the smaller torch. It is a little easier to hang on to.
Yeah, so if you're out there practicing, do this 100 times and feel comfortable that you can do it the same way every time.
And I like to do this, at the start of every project, or even sometimes, halfway through a project. If I'm changing position, if I'm going to go, from horizontal to vertical or something, well, I'll go ahead and maybe mess with the settings a little bit. Change my settings, change hands, try to get comfortable with doing it in a different position. And I'll break out the scrap and just go ahead and make a couple more little beads, just to make sure everything's set up correctly before I get back to working on my sculpture.
Okay.
Okay.
Why don't we try now adding some filler material.
Okay.
And I'll try to stay out of your way.
Oh, come on.
Okay, good arc initiation. Yeah, it's always good to see the puddle just before you add filler. So see the puddle and then dab, dab, and your consistency of dabbing is very, very good. You dab probably 10 to 15 dabs per inch, and there's no right or wrong in doing this. If you dab 8 dabs per inch or 15, just be consistent at it. And you do. You've got the rhythm down, the technique. You're dabbing at the base of the puddle, and it looks good. So you're finishing the weld. You're going to back off on your amperage, taper out so there's no crater cracks. Hold the torch there for 4 or 5 seconds, and you're good. You're golden. Okay, for those of you who don't understand what this device is, it's merely what we call a third hand, or the other hand, and all it's doing is it's holding the piece in place so the part doesn't move around, and it acts as a little extra ground. So if you have a part that you can't quite clamp onto, this little device helps, and you can make these very inexpensively.
Right.
So let's recap, what we've got here.
Okay.
First thing that you did was you ran a bead-on plate. You did not add filler material. You got a very tight arc, meaning low voltage. You were probably in the 9 to 10 volts,
Okay.
which is just optimum. A nice consistent speed. If you ran 5 inches and I ran 6, there again is no right or wrong.
Right,
The
right.
key is to keep the right width, the right height, and that allows you to go to the next step, which you did, adding the filler. You dabbed it. You got really consistent dabs.
Right.
If you look at the profile, the side profile,
Right.
you're not going to see a lot of dips. It's
Right.
a nice, consistent height.
Right.
Okay, and then finally, I want to identify the machines that are out there, because you may have a light duty, you may have what we call a utility welding machine. And when somebody asks me, do I get a utility machine or do I get a heavy duty industrial machine?
Right.
Well, there's a huge difference in cost, and,
Okay.
and there's a reason for it.
Sure.
And let's just talk about, if you're going to build an aircraft, your own private aircraft, a kit plane of some
Right.
sort, you're
Right.
going to build a go-kart or a project, a utility machine is fine.
Okay.
If somebody came to you and says, I'm going to build 100 of them, then you probably want to go industrial. And it just give you a cost comparison.
But it's not like you're going to be building 100 of them at the same time.
No.
You don't need 100 welders running at the same time.
No,
You're only
that's-
going to make them one at a time. So if this machine is good for making one of these,
Yeah.
why wouldn't it be good for making 100 of them?
Well, first of all, you have to take a look at your duty cycle. Duty cycle is a big issue.
right.
If you're building a part and you're cutting a part, you're not welding.
Right.
So you're cutting and fabbing and tacking, cutting, fabbing, and tacking. If you do 100, you're going to cut for 100 and you're going to weld 100. You're going to create an assembly line.
Okay.
Now, this machine won't hold up for that, more than likely.
What is the duty cycle? What do you mean by duty cycle?
Well, for instance, let's just say that this machine is 30%, and I haven't even tested it to the max. But let's say most utility machines are under 30%. Sometimes they're 20%. You can weld at 200 amps for 2 minutes before it overheats and shuts down. Now that's if you're at the maximum of the machine.
Okay.
Now you were welding at 80 to 100, likely that you can weld, for hours without shutting that machine down.
Right.
Okay, so those are the types of things you have to look at when you're looking at buying a machine. Now, if you were to go out and buy the industrial machine, the best of the best, and you see me using different machines, I'll demonstrate the industrial machines because I use them a lot.
Give us a name.
Well, I use a Lincoln V205
Okay.
frequently because I have to carry it with me, and I have to field weld, and I have to make sure that I have the duty cycle available.
And that's a TIG machine also?
It's a TIG machine. It's about $3,700 investment.
Wow.
So
And this machine was?
this machine is under $900.
Wow.
So I mean there's a big disparity, but they are two different animals.
Right.
So just know, if you're building a project, this will more than likely handle your needs.
Right.
And if you start getting high volume, then you may have to upgrade to the industrial.
Oh, interesting. Interesting.
Well, that's it for the DC portion of our TIG welding. Thanks for watching TIG Time.
I'm Kevin Caron.
I'm Mr. TIG.
See you next time. While Wyatt is shaking the dew off the lily, I'm going to go ahead and play with the torch here a little bit.
See how it starts?
Yeah, where I get roasted repeatedly. Jingle bells, jingle bells. That's what I sound like.
I'm sorry. I have to get back out my big shot. Okay. Ready?